Hi guys, welcome to this tutorial. In this tutorial, you're going to learn the Solidity programming language by coding a virtual zombie game. We are going to be coding this game on the CryptoZombies platform. Now, the CryptoZombies platform is simply a free, open source and interactive code school, that teaches you to build games on Ethereum. So the course is designed for beginners to Solidity, and it starts off with the absolute basics. So if you've never coded with Solidity before, don't worry, I'll walk you through step by step. So this is the CryptoZombies platform. You can see right here on my screen. And this is the curriculum page. Okay. And if I scroll down, you'll see there are a lot of sections, right? Now, this first section, it's about Solidity, beginner to Solidity, right? And you see that this section has several lessons, about 6 lessons, and each of these lessons have chapters within them. All right. So it also has a section about decentralized Oracle, Chainlink, and also has a section about advanced Solidity. Things like testing smart contract, deploying, and using truffle, and so on and so forth. So, so basically, going through the courses on this platform will get you started on writing smart contracts with the Solidity programming language. Okay. So we are going to start off by, we're going to start with this first section and with the first lesson, making the zombie factory. So I'm just going to click the start course button to jump right into lesson 1, right? So, okay, welcome to lesson 1. So this is chapter 1 of lesson 1. In lesson 1, we are going to build a zombie factory to build an army of zombies. Our factory will maintain a database of all zombies in our army. Our factory will have a function for creating new zombies, and each function will have a random and unique appearance, okay? So in this chapter, basically, we are going to be, writing the code for basically the functionality for what? Generating new zombies. But in later lessons, we'll add more functionality, like giving the zombies ability to attack humans or other zombies. But before we get there, we have to add the basic functionality of creating new zombies, right? Okay, the zombie DNA and how it works. The zombie's appearance will be based on its zombie DNA. Zombie DNA is simple. It's a 16-digit integer like this. Just like real DNA, different parts of this number will map to different traits. The first 2 digits map to zombie's head type, the second 2 digits to the zombie's eyes, etc. So this number represents our zombie DNA, and our zombie appearance will be based on this number. So like it is said here, the first 2 digits of this number maps to what? The zombie head type. So right here, 8 and 3, what determines the head type of our zombie. Then the second 2 digits maps to what? The zombie eye. So which means 5 and 6 right here determines what? The eye type of our zombie. You'll be seeing much more of this as we go along. Note, for this tutorial, we have kept things simple, and our zombies can have only 7 different types of head, even though 2 digits allows for 100 possible options or combinations. So for the simplicity of our application, we will keep the total number of heads to 7. Even though we could derive 100 possible combinations from 2 digits, right? So, but later on, if we could add more head types if we want to increase the number of zombie variation, right? For example, the first 2 digits of our example DNA above are what? 8 and 3. The first 2 digits are what? 8 and 3 here. So map that to the zombie's head type. We will do this. We'll perform this operation. 83, which is what? The first 2 digits that represents what? That determines the head type of our zombie. Modulus what? 7. Why 7? 7 because we are maintaining a total number of 7 head types. Okay, then plus 1. Then whatever the result is would be the head type of our zombie. So this zombie would have the 7th zombie head type. Okay, so basically this is the formula we are going to be using to derive the head types for our zombie, and even not just head type, other traits of our zombie, whether it's the eye, the skin color, and the rest. This is going to be the formula we'll be applying, right? All right. In the panel to the right, go ahead and move the head gene slider to the 7th head type to see what the traits the 83 will correspond to. So we are going to play around with the sliders on this side of the screen, and see what head type the seventh position will look like. Okay, so let's see. This is the 2nd head type. This is the 3rd head type. This is the 4th head type, 5th, 6th, and then the 7th. All right. So which means a zombie with this DNA here would have this head type. This head type that looks like, a Santa Claus hat. 7th head type. Okay. So a zombie with this DNA here that starts with 8 and 3 as the first 2 digits would have this head type. Okay. Based on the result of this formula, because we got 7 here. So perhaps maybe we have another DNA and that begins with 6 and 0. Okay. That's 60. Maybe we're going to be having a head type of this, or maybe even this, or this, or this, as the case may be. All right. And so this also applies to other traits of our zombie. You can also see there are different head types. Eye types in this case. Different eye types, right? And all these are based on this number. Okay. All these are determined by this number. Okay. So you can see even the shirts, our shirt types are changing respectively. Okay. Then we have the skin color. Okay. Let's see how. So just play around these sliders and see how your and watch how your zombie changes accordingly as you move the sliders. All right. So this is how, the same way our DNA digit, our DNA integer here would determine the appearance of our zombie. So here it says put it to test, play with the sliders on the right side of the page, experiment to see how the different numerical values correspond to different aspects of the zombie's appearance. All right. So just play around with this and watch how your zombie changes. All right. So with that being said, let's move on to the next chapter by clicking the next button right here. See you in chapter 2.
Contracts. All right. Starting with Solidity's code is encapsulated in contract. A contract is the fundamental building block of Ethereum application. All variables and functions belong to a contract, and this will be the starting point of all your projects. An empty contract named Hello World would look like this. So this is how a contract looks like. Now, if you've worked with other programming languages like Java, and you know what a class is, now a contract is very similar to a class in Java or some other object-oriented programming languages. So it behaves very similar. And the way to write a contract in Solidity is this way. You use the contract keyword followed by the name of the contract. Then you have your curly brackets, right? Okay. So version pragma. Now, what is version pragma? All Solidity source code should start with a version pragma. A declaration of the version of the Solidity compiler this code should use. Okay. So the version pragma is simply, declaring to Solidity that this is the version of compiler I want you to use to compile my code. Now, this is to prevent issues with future compiler versions, potentially introducing changes that could break your code. For the scope of this tutorial, we will want to be able to compile our smart contracts with any compiler version in the range of 0.5 to 0.6. It looks like this. All right. So this is how we would tell Solidity, all right, so use this compiler version for our code, right? So this is how you write it with the pragma keyword, then Solidity, then specify the Solidity version you would like the compiler to use. Okay. So in this case, we're specifying a range of version. So we're telling the code that, all right, anything between 0.5 to 0.6 is good. All right. So, but obviously here is, you can see it's less than 0.6. So 0.6 is not included, right? So anything before 0.6, let's say 5, 9, and stuff like that. But 0.6 is excluded, right? But 0.5 here is included because we have a greater than equal to sign. All right. So putting it together, here is a bare bones starting contract. The first thing you will write every time you start a new project. All right. This is the first thing we'll write every time we start a new project. First thing should be declaring the Solidity compiler version at the top that you want your code to use, and then followed by a contract statement, right? All right. So let's put this to test in our own code right here. To start creating our zombie army, let's create a base contract called Zombie Factory. All right. So we're going to create a contract called Zombie Factory. In the box to the right, that's this box over here. Make it so our contract uses Solidity version this. All right. Then number 2, create an empty contract called Zombie Factory. All right. So let's jump right into it. Firstly, let's declare our Solidity version. Okay. So how do we do that? Let's just get rid of these comments right here, and then we can just paste this here. Okay, like so, right? I think we would remove this sign and then put a semicolon. Now, something you need to note in Solidity, each statement in Solidity must end with a semicolon. Now, a statement in Solidity is each line of code, right? So, if you write something like this in Solidity, you must end it with a semicolon, or else the compiler is going to throw an error. All right. Okay. So, number 2, create an empty contract called Zombie Contract. The contract called Zombie Contract. So how do we create a contract? Remember, by using the contract keyword and then followed by the name of the contract. So right here, we're just going to write the contract keyword here, then paste the contract name, the Zombie Factory, right? And then our curly brackets. When you're finished, click check answer below. If you get stuck, you will click hint. All right. Let's click. Okay, voila. So you can see we got it right. So let's move on to the next chapter. Chapter 3, state variables and integers. Great job. Now that we've got a shell for our contract, let's learn about how Solidity deals with variables. So now we've gotten a shell for our contract. Let's go ahead and learn how Solidity deals with variables and integers. State variables are permanently stored in contract storage. This means they are written to the Ethereum blockchain. Think of them like writing to a database. So state variables in Solidity are variables that are stored permanently on the blockchain. They allow us to store data permanently on the blockchain. And the blockchain in reality is much like a database. Okay, think of the blockchain like a database. Because in real sense, that's exactly what it does. It stores data. Just that it stores it in a decentralized way. Okay, it's decentralized. Anybody can have access to it, see what is going on there. Okay, so that's really what a blockchain is in essence. So this is an example of what? Of a state variable that is stored permanently on the blockchain. It's called my unsigned integer and has a value of what? 100, right? In this example contract, we created a uint. Okay, this uint is the data type of this particular variable. It's a uint called my unsigned integer and set it equal to what? 100, and it was set equal to 100. So let's go ahead and learn what a uint is exactly. A uint is called what? Unsigned integers, right? Okay. The uint data type is an unsigned integer, meaning its value must be non-negative. There is also an int data type for signed integers. So basically in Solidity, we have what? Uint and what? Int. These are data types for integers. Now, uints are called what? Unsigned integer. Sorry, I forgot it. Okay, unsigned integers. And why are they called unsigned integers? Because they can only be used with variables that are of a positive value. All right. So 1, 2, 3, 4. Right. Now, ints are called what? Signed sorry, I don't know what's wrong with me. Signed integers, right? Okay. Now, ints are used for signed integers, and these are values like -1, -2, -3, and so on and so forth, right? So these are the two types of data types we have for integers in Solidity. Okay, but this is the mostly used one, the uint. This is the one you're going to be working with a lot. You're going to see this more often in Solidity codes, and yeah. So okay, having said that, let's go ahead. In Solidity, uint is actually an alias for what? Uint 256, a 256 unsigned integer. So basically, in Solidity, when you write a variable with this data type like this, the Solidity compiler takes it as this. Sorry, uint 256. Okay. Now, there are different categories of uint. You can have uint 8, uint 16. Sorry, uint 16, uint what? 32, and so on and so forth, right? So down to uint 256. This is the last and the greatest, the last and the biggest. So what this means in essence is it's just basically describing the size. So this is the smallest, then this is greater, and then this is the biggest, right? So, but whenever you use uint without specifying any number in front, the Solidity compiler takes it as uint 256. Okay, and this is uint 256 is the mostly used one among every one of them. So okay, and yeah, it goes on to say you can declare uints with less bits: uint 8, uint 16, uint 32, etc. All right, as we just said. But in general, you want to simply use uint, except in specific cases, which we will talk about in later lessons. Okay, so let's put this to test. Our zombie DNA is going to be determined by a 16-digit number. Remember when we talked about 16-digit numbers in our first lesson. Now, declare a uint named what? DNA digits. All right, let's copy this and set it equal to 16. Okay, so we're just going to be declaring a uint, something like this here. So I think we'll just go ahead and copy this and then set it equal to 16, and then copy this and change this to DNA digits, and voila. I think that is it. Let's go ahead and click check answer and see if we're right. Okay, great. We are right. On to the next chapter. Math operations, chapter 4. Math in Solidity is pretty straightforward. The following operations are the same as in most programming languages. This is the addition expression, subtraction, multiplication, division. Very similar to how it is written in other programming languages. Then we have also modulus. For example, 13 modulus 5 is 3. Because if you divide 5 into 3, if you divide 5 into 13, 3 is the remainder. So basically how modulus works is that when you divide a number by another number, the remainder gotten is the modulus, right? So yeah, that's how it works. Solidity also supports an exponential operator, that is x to the power of y greater x to the power of y, and this is how it's written, right, in normal mathematical terms. But in Solidity, it is represented this way by 2 asterisk symbols. So this means 5 to the power of 2, which is equal to what? 25, right? So put it to the test. To make sure our zombie's DNA is only 16 characters, let's make another uint equal to 10 raised to the power of 16. That way, we can later use the modulus operators to shorten an integer to 16 digits. So we want to create an integer right now, a variable that is equal to this value, 10 raised to the power of 16. So create a uint named what? DNA modulus. I could just copy this right away and set it equal to what? 10 to the power of what? DNA digits, right? This DNA digit was was what we've declared from our former lesson. So okay, let's start it right now. Let's start by writing uint and then the name of the variable, and then set it equal to what? 10 to the power of what? DNA digits. 10 to the power. And how do we write to the power in Solidity? By using the double asterisks and then DNA what? Digits. Okay, don't forget to put your semicolon. Okay, so I think that is all. Let's check answer, see if we're right. Okay, voila. To the next chapter. Chapter 5, Structs. Sometimes you need a more complex data type. For this, Solidity provides structs. And this is an example of how a struct is written in Solidity. This is a struct called person and has what? 2 properties. Struct allows you to create more complicated data types that have multiple properties. So this is the major purpose of a struct, because it allows you to have a particular variable that can hold different properties. So for example, this person has what is holding different variables or different properties within it. It has a property age, it has a property name. Whereas other data types like these uints we worked with earlier, they could just hold, one value each. But with struct, you can have it hold multiple values, multiple data types. One struct could have multiple data types or multiple variables, properties within it, right? So it's used for more complicated use cases, right? It's much like an object in other programming languages, just like JavaScript. In JavaScript, we have what we call objects, and it's very similar to structs in Solidity. So take note of that. Note that we just introduced a new type, string. Strings are used for arbitrary length, UTF-8 data. Example, string greeting equal to what? Hello world. So we'll be learning more about what string is and how to work with strings as we move on in this course. Put it to the test. So let's put what we've just learned to test now. In our app, we are going to want to create some zombies, and zombies will have different properties. So this is a perfect use case for a struct. Number one, create a struct named zombie. How do we create a struct? By using the struct keyword, right? And then typing out the name of the struct, zombie in this case, right? And then followed by the curly brackets. All right. Number two, our zombie struct will have 2 properties. Number one, name, which is a string, and then DNA, which is a uint. All right. So name, which is a string. So let's type out the data type first, which is string, and then name, followed by semicolon, and then uint, which is DNA, and then semicolon. All right. So let's check answer to see if we're right. And great, we are correct. So let's head to the next chapter. Chapter 6, arrays. When you want a collection of something, you can use an array. There are 2 types of arrays in Solidity. We have the fixed array and the dynamic array, right? And let's look at the differences between the fixed array and the dynamic array. This is an example of a fixed array. So here we have an array called what? Fixed array. And then this is an array of uints, right? This array is an array of uints. And this array of uints has a length of what? 2, which means the length is fixed. So that is why it's called a fixed array. And now, this is also a fixed array, although this is an array of what? Strings. An array of strings. Now, what do we mean by an array of strings or an array of uints? For example, if we have this, if we have something like this, 2, 3, 4, right, and so on and so forth. This can be referred to as an array of what? Uints, because it's an array that is made up of what? Integer numbers within it, right? As elements within it. The elements within it are integers, right? Okay, so and also if we have an array like this that is made up of what? Strings, okay? This can be called an array of what? Strings, okay? So please take note of that. So all right, this is an array of units of size what 2, of length 2, sorry, rather length 2. Then this is an array of strings of length what 5. So these two can be referred to as what fixed arrays because their length has been fixed at the time of declaration, right? Good. So this last one can be referred to as a dynamic array. It has no fixed length and can keep growing, right? Now, why is it a dynamic array? When you write an array without specifying a specific length within the brackets, the Solidity compiler takes it as a dynamic array. Okay, so this is how to write a dynamic array, simply by not specifying any number within the bracket. All right, you can also create an array of structs using the previous chapter's person structs. Okay, using the previous chapter person struct, you can have an array of what? Struct person. Okay, just as I told you, you can have an array of strings or an array of units. You can have an array of structs. So this is how you will write an array of structs. Remember the person, the struct person we dealt with in our last lesson. So this is how you would write an array of person with the name of the array. For example, if we want to write an array of our own struct here, zombie, this would be zombie. Okay, now let's make this Z capital letters because the Z has to be capital because the name of the struct is in capital, right? All right, so and then followed by brackets like this, just the way you would have strings followed by brackets or units followed by brackets. You would also have struct, the struct name followed by what? Bracket. This to tell Solidity that this is an array of this particular struct zombie. Okay, and then followed by the name of the array. You can call the name of the array of what? Zombies. Right. So this would be a simple way of writing an array of zombies. Okay, using our struct. All right, so let me take this off. Okay, remember that state variables are stored permanently in the blockchain, so creating a dynamic array of structs like this can be useful for storing structured data in your contract, kind of like a database. Public arrays. You can declare an array as public and Solidity will automatically create a getter method for it. The syntax looks like this. Okay, so this is how you write a public array in Solidity. And in Solidity, when you declare an array, as public, there is what Solidity does to it. It automatically creates a getter function for it, or a getter method. And what this getter method is simply, a function that can be called to return the value of whatever that getter function was built around for. So for example, now this statement here has created a getter function for the people array. So automatically you can be able to call this statement and it will produce to you the value of people. Other contracts would then be able to read from but not write to this array. So you can actually read the value of people, but you cannot write to it. You can read it because it has a getter method. It can return the value for you, but you can't write to it because it does not have a setter method, right? Okay, so that's the difference. So this is a useful pattern for storing public data in your contract. Put it to the test. We are going to want to store an army of zombies in our app, and we are going to want to show off all our zombies to other apps. So we want to make it public. All right, so would like to make our zombie array public, right? So let's create the array first of all. Create a public array of zombie structs and name it zombies. Okay, and I think we've actually done that earlier. We created an array of zombie, right? So how did we do it again? We started by writing zombie, an array of zombie structs, and then giving it a name. In this case, let's give it the zombie's name. All right. And then remember, we have to make it public. So how do you make it public? By putting in the public keyword here. And then please do not forget your semicolon. All right. So let's check for answer, and good. We are right. Okay. Next chapter. Chapter 7. Function declarations. A function declaration in Solidity looks like the following. All right. So this is how to declare a function in Solidity. This is a function named eat hamburgers that takes two parameters, a string and a uint. You can see it takes two parameters, a name, which is called string, and what? An amount, which is of type uint, right? For now, the body of the function is empty. Note that we are specifying the function visibility as public, okay? So public here is defining the visibility of the function. In Solidity, we have different types of visibility. We have public, we have private, we have internal, and then we have what? External. So all these are the types of visibility we have in Solidity. Let's get rid of this. Okay, so for in this case, the visibility is public. Okay, and we would be learning as we go on in the course what each of those visibility types mean. So just hang on. We are also providing instructions about where the name variable should be stored. That is in memory. Okay, so actually this memory keyword we are using along with name here is simply telling the Solidity compiler what to do, to store this parameter in a memory location. Okay, in the memory location. Okay, so that's just basically what we do. And most of the times, whenever passing a string into a function, you always have to put the memory keyword. It's very important, or else your Solidity compiler will throw an error. Okay, this is required for all reference types such as array, struct, mappings, and strings. Okay, so take note. This does not only apply to strings. It also applies to mappings, structs, and arrays. All these four data types in Solidity requires you to always put the memory keyword whenever passing in those data types as a parameter in functions like this. Okay, please take note of that. We are going to be working with the memory keyword a lot more after this, so you would learn more about it as we move on. Now, what is a reference type? Okay, now it says earlier that this is required for all reference types such as arrays, structs, mappings, and what? Strings, right? Now, what is a reference type actually? So, well, there are two ways in which you can pass in arguments to a Solidity function. Okay, now number one is by value, and you can also pass it in by what? Reference. So we're going to learn the difference now. Now, by value, this means that the Solidity compiler creates a new copy of the parameter's value and passes it to your function. This allows your function to modify the value without worrying that the value of the initial parameter gets changed. I'll explain to you this shortly. Okay, I'll explain to you this shortly. By reference, which means that your function is called with a reference to the original variable. Thus, if your function changes the value of the variable it receives, the value of the original variable gets changed. So let me explain to you what it means by passing an argument to a Solidity function by value. Okay, now let's assume we have this function right here. Let's copy this function and paste it right here. Okay, and now let's take away these parameters in the brackets and pass in our own parameter, and then we are going to pass in an already predefined parameter, DNA digits. Okay, that has a value of 16. So how do we pass it in? You write the data type and then the name of the parameter. All right. So this type of variable, this type of data type is usually passed in by what? By value. Whenever you pass in this type of variable into a function, it's passed in what? By value. Okay, because that is the form of reference type this type of variable has. Okay, so now when you pass in such data into a variable, a data like this, DNA digits, what does the Solidity compiler does? This is what it does. It takes the value and creates a new copy of it and passes it into this function. It does this under the hood. So in that way, whatever modification, whatever update, whatever change we make to DNA digits inside this function, it does not affect the original value of DNA digits, which is 16. So if I come down here and I say DNA digits should now be equal to what? 16, okay, plus what? 10, all right, which actually means 26, right? If I make this change does not affect the original value of DNA digits, which is 16. So if I were to come outside this function and perform an operation and make use of DNA digits, I will still have the value of DNA digits to be what? To be 16, because like I said, this is passed in by value. And like this was defined here, it says this allows your function to modify the value without what? Worrying that the value of the initial parameter gets changed. So when you pass in DNA digits right here, the original value does not get changed, but the value within here remains 26. And if there is any operation you want to perform with DNA digits inside this function, it will be 26 because we've made a change here. But anything outside this function, it's not going to affect the original value. Okay, so that is that. That's what it means by passing in a function, just passing in a variable to a Solidity function by value, right? Now, by reference, this means that your function is called with a reference to the original variable. Okay, thus, if your function changes the value of the variable it receives, the value of the original variable gets changed. Right? So now, what type of data types are usually passed in by reference? These type of data types are the arrays, the structs, the mappings, and the strings. So for example, do we have an array in our code already? Oh yes, we do. We have the zombie array. So for example, let's pass in the zombie array into this function. All right. Okay, so here we go. So if I make any change to the zombies array inside this function, let's say I change the value of the zombies array, or I give it a new array or something like this. Zombies should now be equal to, an array of, here is a new array, right? Now, if I do this for an array, it actually changes the original value of whatever we've declared this array to be. Let's assume while declaring this array, we gave it a value of 1, 2, 3. This is just an example, okay? So if we do this and within this function, we give zombies a new value like this, it will change the original value of zombies, because this is how data types like arrays are being passed into a function. They are passed in by reference. So I hope you got that straight. All right, so let's delete this and then let's continue. Note, it's convention but not required to start function parameters variable names with an underscore in order to differentiate them from global variables. We'll use that convention throughout our tutorial. So like what they're just saying here is, it's a convention, it's a good practice to name your parameters with an underscore at the beginning like this, like so. Okay, right. You would call this function like so. So if we were to call this eat hamburgers function, we'll call it by calling the name and then passing in the value of those parameters into the function. Pass it in like so, and then with your semicolon at the end. So this is how a function is called in Solidity. Now let's put to test what we've just learned. In our app, we're going to need to be able to create some zombies. Let's create a function for that. Create a public function named createZombie. Okay. Remember how to create a function? We start by writing the function keyword and then the name of the function, createZombie. All right. Sorry. And then it says you should take two parameters. This function will take two parameters. Number one, name, and which is a string. So we'll type in string first. And remember, the memory keyword must always be used when working with data types like strings and also mappings, structs, and arrays. Okay. So remember to put your memory keyword whenever passing string into a function. And then followed by what? The name of the parameter, which is what? Actually name. Okay. Then the second parameter is DNA. DNA is a uint. Okay. And then we call it also DNA. Don't forget to pass the first argument by value by using the memory keyword. All right. So we've done that already by using the memory keyword here, and then leave the body empty for now. We'll fill it in later. Okay, so let's click check answer to see if we're right. Okay, we have a little problem here. Oh, okay, we forgot to delete this test code I wrote. We're not going to delete the whole thing, just to delete this and then make it the way it was earlier. All right. What other let's see. Oh, okay. The problem here is that we forgot to make it a public function, right? Forgot to make it a public function. So let's put in the public keyword right here. And then I think we're good to go now. Voila. All right. To the next chapter. Okay, chapter 8. Working with structs and arrays. Creating new structs. Remember our person struct in the previous example, right? This. Now we are going to learn how to create new persons and add them to our people array. Okay. So this is your person struct, and this is our people array of type what? Person struct. Do you understand? This is a people array, but of type what? Person struct, which means this array is going to contain entities that are of this type. Those entities are going to have properties like this, of age and of name. Okay. So this is a people struct of type person array, right? So create a new person. This is how to create a new person. By using the name of the struct and passing in those values for the properties that the struct has. So we pass in, for age, we pass in 172. And then for name, we pass in what? Satoshi. Okay. So this is how to create a person from the person struct by using the name of the struct and then passing in the values. All right. So and then here we're storing this particular data to this variable called Satoshi. And this Satoshi obviously is of type what? Person, right? Now, how do we add this person that we've just created to this array, the people array declared above here, right? We do that simply by using the keyword or a function called push in Solidity. The push function, the push method. So the push method is used to push elements or values into an array. It's simply a method that exists on all arrays. And that method is used to what? Push in values into the arrays, to insert values into the arrays. So we can also combine these together and do them in one line of code to keep things clean. All right. So this here is the combination of what? This line and this line. So right here, what are we doing? We are creating the person like we have above here, and then pushing it at the same time. You see the difference now? So instead of splitting it and having it in two lines, we can actually do both of these in just one line. Create the person and then push it inside the array. All right. So this makes our code looks cleaner, more simpler, and easy to read. Note that the array.push method adds something to the end of the array. So the elements are in the order we added them. See the following example. Okay. So what this is simply saying is the order at which you add them into the array is the order they will be positioned in the array. So in this example, we have what? We have 5 was pushed in first. That's why 5 is first in the array. 10 was pushed in second. 10 is second. 15 last, and 15 is in the last position, right? So in the order in which we insert them is how they would appear in the array. Okay, so let's put this to test. Let's make our create zombie function to do something. Fill in the function body so that it creates a new zombie and adds it to the zombies array. All right, let it create a zombie like this and then add it to the zombie array like this. Or you can even do everything on one line like this. Okay, the name and the DNA for the new zombie should come from the function argument. All right, let's do it in one line of code to keep things clean. Okay, so in this create zombie function, we want to what? Create a zombie and push it into our what? Zombies array. So how do we create a zombie? First of all, by using the zombie what? Struct. Okay, so we just say zombie right here. Remember how they did this? See how they created person right here? We're going to be doing something similar with zombie. All right, now what are we going to pass in? We're going to pass in the values of what? Name and DNA. And remember, we have name and DNA coming in as a parameter from our function. So we'll just simply pass it in right here. What? Name, and then what? DNA, right? Okay. Remember your semicolon, please. Okay. So in this case, we have created a zombie like this, right? We have created a zombie. Now, what do we want to do? We want to also insert this zombie we've created into our zombies array. How do we do that? By saying also zombies, that's the zombies array we have here, right? We're accessing the zombies array we have here. Dot what? Dot push. Dot push. And then what do we want to push? We want to push this whole zombies we just created. So let's cut it rather, and then paste it inside the brackets. And I'm sorry, this semicolon should be outside, right? So we've kept everything on one line, you know, just as they did right here. So we created a zombie and then pushed it into the zombies array. And so let's click check answer to see if we're right. And voila, we're right. Let's go to the next chapter. Chapter 9, private and public functions. You remember in the last chapter, I explained that there are different types of function visibility in Solidity. Remember I said we have the public, and then we have private. Private, right? And then we have internal, and then we have external, right? So in this chapter, we are going to be treating these two, public and what? Private. Okay, these are the two main types actually. The other types are used, they're used in some occasions, but not as commonly used as these two. So we are going to be looking at these two in this chapter. All right. So in Solidity, functions are public by default. This means anyone or any other contract can call your contract function and execute its code. Obviously, this isn't always desirable and can cause your contract vulnerable to attacks. Thus, these Thus, it's good practice to mark your functions as private by default, and then only make public the functions you want to expose to the world. All right, so what this is saying is marking the function public could lead to several, downsides, because it could make your contract vulnerable to attack. Because when you mark a function as public, the function is exposed to the external world, is exposed to the, to the world outside, to anyone, or to any other contract. So it can be hacked. Do you understand? It can be vulnerable. It can be exploited. So it's good practice to mark your function private by default, and then if there are certain instances where you see the need for a function to be public, you can then make it public. So let's look at how to declare a private function. This, for example, is how to declare a private function. There's a function, the name of the function, then the private. So the only difference here is what? The private keyword that was being used there. Okay? This means only other function within our contract will be able to call this function and add to the numbers array. So when you declare a function with the private visibility, it means our contract sees it. It means that this function or that function, that particular function, can only be called or be accessible by functions within our contract. Anything outside our contract or anyone outside our contract cannot have access to that function. All right. It's only accessible within our contract. As you can see, we use the keyword private after the function name. Okay. Like this. And as with function parameters, it's convention to start private function names with an underscore. Do you see right here? The function name was started with an underscore, right? So it's also a convention. It's also a good practice to start private function with an underscore, right? Take note of that. Now let's put this to test. Our contract zombies function. Our contract zombie function is currently what? Public by default. Yeah, you can see we have this public by default. This means anyone could what? Call it and create a new zombie in our contract, and which we don't want, right? Let's make it private. Modify create zombie to a private function. Don't forget the name convention. Okay, so let's change this to private, and then since it's a private, let's put an underscore just for the sake of what? Convention sake. Just for convention sake. Okay, so so that's just how it is, changing a public function to a private function. All right, with this I think we're correct. Let's check answer and see. Oh, great. Oh, all right, so the next chapter. Chapter 10, more on functions. In this chapter, we're going to learn about function return values and function modifiers. Return values. To return a value from a function, the declaration looks like this, right? So this is how you write a function when you're returning a particular variable or data from it. You can see here it specifies that this function returns a value of type what? String, right? And as you know, we must always put the memory keyword here whenever we're working with strings, right? So this function returns the greeting variable that has been declared up above, and it is of type what? String. So that is why in this case we have string in the brackets. So perhaps in another case we're returning a number or something from this function, right? The data type that we're going to put in this bracket will be probably uint or integer, as the case may be. So that is that. In Solidity, the function declaration contains the type of the return value, in this case string. So that's what we've seen here. In this case, it is string. In other cases, it could be an array. So in other cases, it could be a uint. In other cases, it could be an integer. It's the function modifiers. The above function, that is this function, doesn't actually change state in Solidity. E.g., it doesn't change any value or write anything. All right, what is the meaning of change of state in Solidity? Now, change of state in Solidity is simply modifying the value of any variable at all. So whether be it an array or a struct or a string value or a uint value, as long as you modify the value of a particular data in Solidity, that is what is called change of state. So for example, we have this greeting variable over here, right? And it's the value of the greeting variable is of type what? It's of type string. What's up, dog? Okay. Now this is the value. What's up, dog? But if I come over here on this next line and I give greeting a new value and say this is a new value, this is going to be a change of state in Solidity. This is what we refer to as change of state because we've modified the original value of this particular variable. So that is what change of state means in Solidity. All right. So what is said here is that this function above does not actually change state in Solidity. It doesn't change any values or write anything, right? It doesn't change the value of greeting, right? And neither does it create a new value of anything at all. What it just does is that it accesses this value of greeting and returns it. So these type of functions are called view functions. So in this case, we'll declare it as view, meaning it's only viewing the data, but not modifying it, all right? So you see the function here is being rewritten with a view keyword here. So this tells Solidity that, all right, this function is a view function. It doesn't change the value of any variable or it doesn't change states in the application. It simply views the data and that's all. It simply views the data and might return it, but it doesn't change or modify any state at all. Solidity also contains pure functions. Now, we have another form of modifier in Solidity called pure functions, which means you are not even accessing any data in the application. All right, so there's a major difference between a view and a pure function. In a view function, you can access the data, but you won't change the state. But in pure functions, you don't even access any data in the application, right? Okay, so just as we were accessing greeting here, greeting is the data in the application above. But for pure functions, you don't even access any data in the application at all. Now, this is an example of a pure function right here. You can see that the data we are returning here, the multiplication of A and B, is actually data or actually variables or parameters that has been passed into this function. Okay, they are not any sort of predefined variables in our application, like in this case we have in with greeting, right? With greeting. So that's the major difference between a pure and a view function. The function doesn't even read from the state of the app. Okay, are we reading any value from here from the state of the app? Nope. The values we're returning here are parameters in this function. Its return value depends only on its function parameters. All right, just as we've said. So in this case, we will declare the function as pure. Note, it may be hard to remember when to mark functions as pure or view. Luckily, the Solidity is good. The Solidity compiler is good about issuing warnings to let you know when you should use one of these modifiers, right? So as a beginner, you might find it a little bit daunting at first to clearly ascertain which function should be marked as view or pure. But the Solidity compiler does a very good job at marking or throwing errors or showing warnings that, all right, this function should be a view function, this function should be a pure function. All right, so let's put it to test. We are going to want a helper function that generates a random DNA number from a string. All right, so we want to create a function that will generate a random DNA number from a string. And now, number one says create a private function called generate random DNA. It will take one parameter named string of type string and return a uint. So this function is going to be returning a value of type uint. Don't forget to set the data location of the string parameter to memory. All right, so let's jump right into it. So how do you create a function? By using the function keyword, remember, and then followed by the function name, and then the parenthesis. Now, what parameters does this function take? So we were told that this function takes one parameter named what? str of type string. So let's insert this parameter right here, string, and then remember the memory keyword must always be there when working with strings, and then the name of the parameter, right? So remember, this is going to be a private function. So let's mark it as private, right? And then what next? It returns a value of type uint. So let's declare it right here. Returns a value of type uint, right? Okay. So I think that is that. All right. And the next, number 2 says, this function will see some of our contracts variables, but not modify them. So mark it as view. So we are going to be viewing some variables in our applications inside this function, but we are not going to be modifying any. So in other words, this function is a typical example of a view function. So we're going to type view right here. Okay. Then number 3, the function body should be left empty at this point. We'll fill it in later. All right. So I think we're done. Let's check our answer. Voila. Let's go to the next chapter. Chapter 11. K-Shack and Typecasting. We want our generate random DNA function to return a semi-random uint. How can we accomplish this? Ethereum has the hash function K-Shack256 built in, which is a version of SHA-3. So, what is a hash function? Basically, a hash function is simply a function that takes in a set of inputs and maps it or turns it into a string of fixed length. Yeah, most of the times it's usually random. Not even most of the times, always. It's always a random string of fixed length, right? So, for example, let me show you an example of how the hashing function works. This is a website by Andrew Branworth. So this website has a hashing algorithm here that we can use to explain how hashing works. So right here is an input field, and this is the hashing field. So I am going to put in values in this data, in this input field, in this data section, and then you will see the corresponding hash it produces. So if, for example, let me type in ant, you can see that as a type, it changes, right? So this hash function changes even at the slightest change you make to the original data. So for example, this is ant. So if I should delete the t at the end, you'll see that it produces a hash function that is totally and entirely different, right? Look at this. Okay, you see that? All right, so this is how hashing works. It takes in a set of inputs, a set of strings, and produces a string, a long string of fixed length. This length is usually fixed. You can see that the length, no matter how I type in this field, the length still remains the same. You see that? The length still remains the same, but always unique, always unique. All right. So that is how hashing works. So Ethereum has an inbuilt hash function called K-Shack256. A hash function basically maps an input into a random 256-bit hexadecimal number. A slight change in the input will cause a large change in the hash, right? Just as we've seen on that website. It's useful for many purposes in Ethereum, but for right now, we are going to use it for pseudo-random number generation. Okay, so hashing is used for many purposes, but right now we want to use it to generate random numbers for our application. Also important, K-Shack256 expects a single parameter of type bytes. So this inbuilt hashing function that comes with Ethereum expects one very important parameter, and that parameter must be of type bytes. This means that we have to pack any parameters before calling K-Shack. So because when you're working with K-Shack, it can only accept a parameter that is of type bytes, right? And for this reason, we have to pack whatever parameter we are passing into the function. So you can see right here, this is an example of how this string is being packed. So we do not just pass in the string directly, we have to pack it. So this function abi.encode path is actually the function responsible for converting it to type bytes that is compatible with the kshack function, right? So take a note of that. And then you can see here also that the only difference between this string and this string is the last letter, which is C. Then this one is B, right? But you will notice that the hash function produced, or the hash string that was produced, is totally different, even though it was just a single letter we changed. So that is how hashing works. As you can see, the return value are totally different, despite only a 1 character change in the input, right? As we said earlier. So note, secure random number generation in blockchain is a very difficult problem. Our method here is insecure, but since security isn't our top priority for zombie DNA, it will be good enough for our purposes. So this hashing method is not 100% secure, but since we're just using it for the purposes of learning, we don't want to bother much about security. All right, typecasting in Solidity. Sometimes you need to convert between data types. Take the following example. All right, so look at this example right here. First, we have a uint value, and it's equal to what? 5. Secondly, we have a uint 8 value, and is equal to 5. And here we have a uint value, and it's equal to 6, right? So these two variables are of different data types. Uint 8 is different from uint. Now remember, in our past lessons, we talked about the different categories of uints we have. So remember, we said we have uint, which is defaulted to what? Uint 256, right? Whenever you write uint without stating any number after it, the Solidity compiler simply takes it as the uint 256, right? So other than that, we also have uint 128, okay, and then we have uint 64, okay, and we have uint 32, okay, and then and so on and so forth. Sorry, 32, and then we have uint, you know, I think, and then uint 8, and so on and so forth, down to uint 8. I think, yeah, uint 8 is the last. Okay, so remember we talked about this in our last tutorial. Okay, so in this case we have a variable of type uint 8, and this one is of type uint, so which means it's actually a uint 256. Now this line of code here, we're performing the multiplication between A and B. That's 5 times 6, and we are storing the result in a variable called C, which is set as a uint 8 data type. Now this is going to throw an error, right? This is going to throw an error because A and B are of two different types. A is a uint 8 variable, while B is a uint 256 variable, right? So the multiplication between the both of them is simply going to throw an error because you're trying to store them. You're trying to store the value in a uint 8 variable. All right. Now it cannot work. This can only work when the multiplication between these two variables are of the same types. That is, A and B should be of the same type, right? So what can we do? We can cast the B's variable down to a uint 8. Currently, B has a data type of uint 256, but we can cast it down to a uint 8 so that this does not throw an error anymore. The multiplication goes successfully and it is stored successfully in a uint 8 variable, which is C. So how do we typecast? Now, this is how to typecast. You typecast by wrapping the variable with the specific data type you want to cast it to. So we want to cast B to a uint 8. So you can see we just wrap it with a uint 8 data type in brackets, right? So in this case, This is now a uint8 variable multiplied by uint8 variable, and then we can successfully store it in a uint8 variable of C. All right, so that's how typecasting works in Solidity. In many cases, you will need typecasting, as you work more and more with Solidity programming. In the above, A times B returns a uint, right? But we are trying to store it as a uint8. A times B returns a uint, but we are trying to store it as a uint8. That is why it throws an error, which could cause potential problems. By casting it as a uint8, it works and the Solidity compiler won't throw an error. All right. So by typecasting this down to uint8, it works because they are now compatible with each other and also compatible with the type of the storage variable, which is C. Let's put this to test. Let's fill in the body of our generate random function. Here's what it should do. All right. The first line of code should take the K-Shack hash of ABI encoded packed and then our string variable to generate a pseudo random hexadecimal, typecast it as a uint, and finally store the value in a uint called round. All right, so let's take this. Let's jump right into it. So first of all, we want to what? We want to convert this to a byte. And how do we convert this to a byte? By using this function right here. So let's copy this. All right. Now, remember that we have to use the K-Shack 256 function, hashing function, to what? To get the hash of this input. Remember, we're getting string from the function above, right? As a function parameter, we are getting it from the parameter. It's being passed as a parameter to our function, and so we are trying to find the hash of the value string. All right. So this gives us the hash, and then we want to store it in a uint called round. So let's store this in a uint called round. All right. Remember to put your semicolon right at the end. So, and remember, we want to typecast it to a uint, because remember that this function returns a uint. This function declaration specifies that it returns a uint. So how do we change this to a uint? And given that the value that is being returned here is a string originally, so we want to typecast this to a uint. So how do we do that? We just simply come here and then wrap this whole thing in a uint, right? Wrap this whole thing in a uint data type. Uint data type. All right. So by doing this, the string that is gotten from this hash function is then typecasted into a uint and then stored in the round variable, which is of type uint. Okay, good. So number 2, we want our DNA to only be 16 digits long. Remember our DNA modulus that we worked from right here, right? This DNA modulus. So we're going to be using this now. So the second line of code should return the above value modulus, DNA modulus, right? So we want to return this result after pairing this up, the round variable, pairing it up with the DNA modulus value. So how do we do that? So we just say, return. Now, the value of round that we've gotten from the line above, modulus 1, modulus this, okay? So this, and then your semicolon, right? So let me go over this quickly. This is a generate random DNA function, and then in this function we are passing in a string parameter, right? And inside the function, what are we doing? We are hashing the string, and then when we get the hash of the string, we are typecasting it to a uint, right? And storing the value in a round, and which is of type uint. So now, because we want to make the rand variable or the rand digits to not be more than 16 digits long, we need to pair it up in a modulus operation with whatever with the DNA modulus, right? With the DNA modulus value. So let's check for the answer right here. All right, great. Next chapter. Chapter 12. Chapter 12, putting it together. We are close to being done with our random zombie generator. Let's create a public function that ties everything together. We are going to create a public function that takes an input, the zombie's name, and uses the name to create a zombie with random DNA. All right, so let's put this to test. Create a public function named create random zombie. All right, I'll just copy that right away. It will take one parameter named name. All right, a function is going to be taking one parameter called name, a string with data location set to memory. Note, declare the function public just as you declared previous functions private. All right, so let's go ahead and do this. All right, function. Okay, and then the name of the function is create random zombie. So this function is going to be taxed with the purpose of creating zombies for us, you know. So, and it's going to take a parameter of what? String, and remember the memory keyword, sorry, and then the name of the parameter is name. All right, so remember it's a public function, right? Public function, yeah, public function, and then we can put curly brackets. And I think that's all with number one, right? Because name, public. All right, we've gotten down number one. Then number two, the first line of the function should run the generate random DNA function on name and store it in a unit called what? Rand DNA. So the first line, we're just going to create a variable called rand DNA, right? Sorry, there should be a D here, all right? And then set it to the result of the generate random DNA function call. So we're going to call the function here, and then yeah, it says the first line of function should run random DNA function on name. All right, so we're going to pass in name right here. Okay, good. So what is this simply doing? There's a create random zombie function that receives a parameter of what? Name. That's the name of the zombie, right? And then we are using the name to generate a DNA, to generate random DNA. And then we are storing that random DNA into this variable. Remember, our random DNA function is the function we have above here, you know? Okay. I think that is that for number two. Then number three, the second line should run the create zombie function and pass it name and random DNA. All right, this is the create zombie function that we have here. So we want to, okay, we forgot to put our semicolon here. And then this second line should run the create what zombie function, and then pass it what? Name. Pass it name and what? And rand DNA. Okay, then our semicolon right there. Okay, so you can remember that this function takes in two parameters: name of type string, you can see it above here, and rand DNA of type what? Uint, right? And this function, actually, what it just does is that it creates a zombie and then pushes it into a zombie array. That's what that function does. It creates a zombie and pushes it into a zombie array, right? The fourth option says the solution should be 4 lines of code, including the closing brackets of the function. All right, I think, yeah, we got that right. 1, 2, 3, and 4. All right, let's check answer. Great. All right, next chapter. All right, chapter 13. We're almost coming to the end. And if you've gotten this far, then you must really be killing it, you know. Yeah, so our contract is almost finished. Events, chapter 13, events. We're going to be talking about events. Our contract is almost finished. Now let's add an event. Events are a way for our contract to communicate that something happened on the blockchain to your front end, which can be listening for certain events and take action when they happen. So if you've ever worked with other programming language like JavaScript, you'll be very much familiar with how events work. So events are simply just functions that are fired when a certain action is taken. Actions like clicking on a button, closing a page, clicking on an input field, all those things that a user has a tendency of doing on a website or on a web page are called events, right? So yeah, this is an example of how to declare an event by using the event keyword followed by the event name, and then you pass in parameters that event depends on, right? So this is how to declare an event, and I think this is how to fire the event. Okay, the declaration of the event, and then this is how we can make use of the events. Now take this function for example. This is a function add that returns a uint, right? It's a public function, and then what does this function do? It simply declares a result variable and then sets it to the addition of x and y that we got from there as a parameter from the function. Then fire an event to let the app know the function was called. So this is how an event is fired in Solidity. Use the keyword called emit followed by the name of the event that we declared, and then pass in the respective values, the respective values that it's supposed to receive. So we have x here, passing y, which is this, then passing result for this, right? And yeah, doing this, you're emitting an event, and over on the front end, our application can listen to this event to perform certain actions, right? So then lastly, we're returning the result value, okay, which is a uint, right? So this is just a very basic and simple way of using an event, declaring and implementing an event. So your front-end app could then listen for the event. A JavaScript implementation would look something like this. So this is how on the front end, that uses JavaScript, this is how the implementation of listening to the event that comes from the blockchain will be. So you can see your contract, that is our contract, our zombie contract, dot intergers added. Remember, intergers added is the name of our event on the smart contract, right? On the back end. Yeah, the smart contract, the smart contract is the back end of the application, right? So this code is how the front end, that's our JavaScript front end, will be listening and then executing a certain function or certain action based on when the event is fired, right? So when we fire this event, our front end will listen for the event like this and then carry out a particular action, do something with whatever we got, right? So we're listening to the event here, and within this bracket, we have a function that is going to run immediately. The front end receives this event. Immediately the front end listens to this event and it is being fired, then this function will run, right? To do something with the result. So let's put this to test, all right? We want an event to let our front end know every time a new zombie was created. So the app can display it. Now, another thing to take notice, for this tutorial, for this course, we are not going to be covering the creation of the front end. All right. This tutorial is majorly for the back end, which is the smart contracts part, right? So the front end is already being created by CryptoZombies, right? It's already there for us. But this tutorial is majorly on learning Solidity and smart contracts. So we are not going to be creating the front end, all right? So, but yeah, so let's create an event, all right? Declare an event called new zombie, right? Okay, it should pass zombie ID, which is a uint, name, which is a string, and the DNA, which is a uint, right? So let's create an event called new zombie. All right, so we'll declare our event right here. And how do we declare an event? Use the event keyword first, then paste the name of the event, and then what parameters is this event going to work with? So it said zombie ID, which is a uint. So zombie ID. Then the next is a string. Remember, we must always put the memory keyword, all right? So name, all right, and the last is the DNA. which is a uint DNA. All right. All right, great. So here we go. Remember to put our semicolon right here. And yeah. So number 2 says modify the create zombie function to fire the new zombie event after adding the new zombie to our zombies array. All right, so we're going to modify the create zombie function to fire this event we've declared above. And then what happens? Yeah, we're going to do that right after we've let's see. It says modify the create zombie function to fire the new zombie event after adding the new zombie to our array. All right, this is where we add a new zombie to array. So let's fire the event. See, how do we fire an event? Using the emit keyword, and then calling the name of the event, which is new zombie in our case. All right, and then passing in those parameters that the event needs. And where do we get these parameters from? The parameters are already passed into a function, so we can just access it here. Okay, except the zombie ID. So let's see. Let's just pass in the zombie ID. We don't have it in this function. Okay, I think we'll need to create that. Yes, but we'll just pass in the ones we have access to now. That is name. Sorry, name. And what? And DNA. Okay, name and DNA. Then DNA and name. All right, so we'll still need to generate a zombie ID, and I think that is what number 3 is asking us to do. It says you're going to need the zombies ID. Array.push returns a uint of the new length of the array, right? And since the first item in an array has index 0, array.push -1 will be the index of the zombie we just added. Store the result of zombies.push -1 in a uint called ID. So we can call this new zombie event in the next line, right? So how do we do this? All right, so we would have to create an ID for each zombie that was created. And so what were we asked to do? It says array.push -1 will be the index of the zombie that was added. And we already have an array.push here, right? Okay, and so if we set this to -1 here, -1, it will give us what? An ID. Okay, an ID. We can call that ID actually, right? Yes, it was ID. We'll ask to call it here. So this is going to return an ID, right? An integer value. We're going to store it right here. So because this returns an ID because array.push -1 returns array.push in itself returns an ID. Whenever you push a value or whatever into an array, that push function returns an ID. Okay, that's the index of the position is going to be in that array, right? So this function, this array.push function, it's built to automatically return an ID, or that's the ID in this case is the index of the position of the element in the array. All right, so we are going to be putting a -1 to it, and then whatever value we get from this expression will be stored here, and this will serve as our ID, and then we can now use it down here, down here in our emitted events. All right, so that is that, and I think we should be correct with this. Let's try it out and see. Check answer. Okay, we're missing something. All right. Where are we wrong? Okay. All right. We do not need the memory keyword here. Okay, we don't need the memory keyword there. It's only when declaring functions, not when declaring an event. Okay, so yeah, we don't need the memory keyword there. Let's try it again, and voila, here you go. So next chapter. All right, so chapter 14, but 3.js, right? So let's go over what they have for us here. Our Solidity contract is complete. All right, we finished writing the contracts. Now we want to write a JavaScript frontend that interacts with the contract, right? Now, Ethereum has a JavaScript library called web3.js. In later lessons, we will go over in depth how to deploy a contract and set up Web3.js. But for now, let's just look at some sample code for our Web3.js, for how Web3.js would interact with our deployed contract. All right, basically, Web3.js is a JavaScript library, for working on the front end. It's used on the front end to interact with our blockchain or smart contracts application that we have been writing. So on the front end, this is the library that is being used to interact with all the smart contracts code we've been writing so far. So basically, we're not going to, but this course it's not going to cover how to build the front end. What you hear is just a simple explanation of how this Web3.js interacts with our contract. Now, don't worry if this doesn't make any sense yet, because this probably won't make any sense to you, especially if you're not familiar with JavaScript, front-end JavaScript. But I will just go over this and run through this so quickly. But don't worry, like I said, if this doesn't make any sense yet. So all right, so we have a variable ABI here. We're going to create an ABI. We're going to generate an ABI. ABI simply means application binary interface, and here we get our zombie factory contract. How do we get it? By using Web3 with Web3.js API, calling Ethernet, and then contract with the ABI from above passed in, and then the contract address is stored here, and then the zombie factory is stored here. How do we get a zombie factory? By combining the contract address with what? With the zombie factory contract, right? So, and then this is a button, and then a click function that is tied to it, and then this function calls our contract create zombie function. All right, so there's going to be a button that creates a random zombie. In short, that's what this is saying. And then this is a code that listens for the event when a new zombie is created. Like we did in our last lesson, we created an event for new zombie. So this is how we're going to be listening to the event on the front end. All right, so zombie factory dot new zombie, which is the event, and then when this event is being fired, and the front end listens to it, this corresponding function will be called. All right, and so this is going to generate a zombie for us, and and then this take the zombie DNA and update our image. So this function is going to take the DNA that we got from generating a zombie, and then these are just some while statements. But basically, what this function is doing is using the DNA to create an image, right? So, but don't bother about all these details, okay? Because this is not really the scope of this lesson. But so that's basically what it's going to do. What our JavaScript then does is takes the value generated in zombie details, all right? These zombie details here. All right. Our frontend takes the value generated in these zombie details above and use it and use some browser-based JavaScript magic. We're using Vue.js to swap out the images and apply CSS filters, right? You will get all the code for this in a later lesson. Okay, so basically we're just manipulating the DOM right here with some JavaScript, and then adding CSS filters to it based on these zombie details, and then we're generating an image with it. So don't worry too much about that, but that's just the brief explanation of what is happening here. So okay, give it a try. Go ahead, type your name in the box on the right and see what kind of zombie you get. Once you have a zombie you're happy with, go ahead and click next chapter below to save your zombie and complete lesson 1. So remember, our random DNA, if you remember the code we've been writing so far, our random DNA is being generated by our name, right? Okay, let me take you back a bit to show you this, right? Okay, if you look at our code here, you can see that the random zombie is created by taking in the parameter of what? Name. And then this parameter is used to generate this name parameter, right? Is used to generate what? A random DNA, and then it is stored here, and we use this random DNA finally to what? To create a zombie. pass in the name and then the random DNA. And this creates a zombie for us right here, right? So that's exactly what is happening here. You'd see that's exactly what is happening right here. It takes in a name, and if you watch me now, if I type a name in here, you would see how the zombie would change accordingly, all right? So Daniel, that's my name. Did you see? And so each time I alter whatever is in this input box, you see that the DNA or the appearance of the zombie changes, okay? And it's unique, 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 right? DNA, all right? So, okay. So that is that. So this is the name field, and then the name is used to generate a random DNA, and our front-end code, which is this, is what is responsible for changing the appearance accordingly, right? So that is that. All right. Okay, I think we're done with this whole lesson. Let's move on to the last. All right, congratulations, you have completed lesson 1 of CryptoZombies. You're officially one step closer to building your own game on Ethereum. All right, so you can share your progress on Facebook or on Twitter. All right, so yeah. All right, so I'll see you in lesson 2. Okay, see you in lesson 2. Bye.